Hello and welcome. This is Bijan Hushiar. This internet network is configured with IPv4 addressing. Routing is configured. There is end-to-end connectivity. Our objective is to create the standard IPv4 access control lists to prevent PC1A from accessing any devices in the network of 192.168.2.0. Since it is a standard access control list, it can only filter based on source IPv4 address. Therefore, we need to know PC1's IPv4 address. Since it is the standard, it is recommended to be placed close to destination, so we are going to apply it to G01 of router 2, and therefore we have to create it on router 2. But first, let's take a look at the IPv4 address of PC1A, 192.168.1.1, and the IPv4 address of server 2 is 192.168.2.2. The IPv4 address of PC2 is 192.168.2.22. Let's first test to make sure there is end-to-end connectivity between the network that PC1A is residing in and the network that PC2 and server 2 are residing in. So we go to command prompt of PC1A, and we're going to ping server 192.168.2.2, see if the replies are coming back. 4 echoes are going to be sent. We are expecting 4 echo replies coming back. For the first ping, you may lose one of the echo replies back. That's okay. There is end-to-end connectivity. Let's test connectivity with PC2 that has the IPv4 address of 192.168.2.22. See if there is connectivity there. 4 echoes are going to be sent, and we are expecting 4 replies back. Here you go. All 4 echoes are coming back. There is end-to-end connectivity. Now we are going to go ahead and create the standard access control list on router 2. We access the command line interface. We go to privilege mode. Then from here, we are going to perform a show command, show access -list, to see if there is any access list on this router. There is no. Then we access global configuration mode, conf-t, when we start creating a numbered standard access control list with this command, access -list. Then I have to place a number. If that number is between 1 through 99, it indicates it is a standard. If it is between 100 and 199, it indicates it is extended. We are creating a standard, so I can use any number between 1 through 99. None of them is already used. I start with 1. Then I want to deny host 192.168.1.1. Press enter. Since there is a deny any at the end of any access control list, it is implicit. We don't see it. If I don't have any command to permit somebody, all traffic will be filtered and not reach the network that server 2 and PC2 are residing. So I add a permit command with access -list 1 permit any. Then I have to apply this access control list to G01 interface of the router 2, which is the closest interface to the destination network. So I access that interface G01 IP access dash group. Then the number or the name that we apply to the access control list, we use a number 1. The direction the packets are going to go out of that interface to reach the destination network, so out. Let's put this one into test. Let's go to PC1A and see if we can ping any one of those two PCs, PC2 and server 2. First, we are trying PC2, destination host unreachable. Then we try server 2, destination host unreachable. Now, let's see if somebody else from this network can reach the network of PC2 and server 2. We go to PC1B and ping 192.168.22. See if this PC can reach that destination network. It can. So the access control list was only applied to PC1A, and that's the way we wanted it. This is how you create a standard numbered access control list. Now I'm going to remove this access control list that we created. I removed it from the G01 that we had applied it to, and then I'm going to remove the access list one together, and then I'm going to perform do show access list. See if anything is no access list exists because I removed it, and right now PC1A should be able to ping PCs in network of 192.168.2.0. Okay. Now I want to create a named IPv4 Standard Access Control List to perform the same thing, to prevent PC1A from reaching this network, but to allow PC1B to reach that network. Since it is standard, I have to apply it to G01. I mean, it is recommended to apply it to G01, which is closest to the destination network. Therefore, I have to create it on router 2. I could do it on router 1. There is no rule against it. So let's go ahead and do it on router 2. IP access list. Since it is named, I start the command with IP, not access list. And after that, I don't put a number. I indicate whether it is standard or extended, with this keyword, standard for standard, extended for extended. Then I give it name, no PC1A access, no PC1A access. Then I'm going to deny host 192.168.1.1, which is the IPv4 address of the PC1A. Then I'm going to permit any. Otherwise, everybody would be prevented from accessing the destination network. And I'm going to apply it to interface G01 with the same command, IP access dash group. Since it is a named standard access control list, I have to type the name of it, which is no PC1A access, the direction of it is outwards. I think I misspelled that. That's a no. Okay. No PC1A access, no PC1A access with dashes separating those three words. That's it. It is created. Let's put it to test again. PC1A should not be able to ping PC2 and server 2 anymore. As you notice, destination host unreachable, but PC1A should be able. So that's how you create both named and numbered standard IPv4 access control list, which can only filter based on source IP address.
Thank you for watching. If you liked the video and you found it informative, please don't forget to recommend it to others who may be interested. Thank you.